Wait, let me just make sure everything works first. Meanwhile, you can just see fractal. Wait, let me just make sure everything works first. Meanwhile, and yeah, of course, I am hearing my own voice. Okay, I should have expected that. But that means my audio works. Of course, I am hearing my own voice. Okay, I should have expected that. But that means my audio works. Of course, I am hearing my own. Okay, yeah, I know my camera is still black. I will turn it on in a moment. Yeah, of course, Jamboard is no longer working. What is the tool to like write? Um, what's it? What's the whiteboard application that I can use on the browser? Uh, Let me just Google online whiteboard. Start a whiteboard. Paint program. Yeah, I guess that works. Yeah, and I'm actually using my Windows right now, so I can definitely use that. I've always been using Jamboard for this, but then Jamboard is now shutting down. Okay, I found this web whiteboard.com. Okay, let's just do this, I guess. Okay. Uh, when can we expect results to come out? The results has come out actually. During the contest was live. Okay, let me paste this here. During the contest was live, there is a live scoreboard. So I guess like yeah, day one result is out, but obviously day two is 2 days from now, I think. So like tomorrow is an excursion day, and then the day after tomorrow will be the second day of the competition. Um, and yeah, we will know the full result there. Like then, sorry. But yeah, this is basically halfway point of the competition. Yeah, there is one gold for Singapore, two, and then two bronze, I think, right? Yeah. So one gold, one silver, two bronze, which is great because we didn't get any gold last year. Um, I can submit my solution. No, I don't think so. I haven't found a mirror anywhere else also. So today let's just mind solve this where I explain how I solve the problems, but I might code some of them, especially problem B because it's interactive, and with the interactive problems, there is like a testing tool that I can use to test my solution easily. Um, so yeah, for problem B, I might code it, but for the other problems, because we can't really submit it, I don't know whether it's worth coding it. I mean, I guess I can still code it, so you can see how I code it. But yeah, so used to OI having three problems, super confused when you saw someone at 358. Yeah, uh, in EGOI, there are four problems. I think that has always been the case since the beginning of EGOI. Yeah, and the main and also like another important difference with IOI is that they always solve the problems. So yeah, I guess it. Yeah, EGOI is supposed to be uh like the problems itself is easier than IOI. So like yeah, I think they also try to help with like making the problems sorted in expected difficulty. So yeah, that's also another important difference compared to IOI. Okay, yeah, the link of the problem is in the description. I can paste it again in the chat, I guess. This year I think they also do like they don't publish the problem until the competition day finishes, which is a bummer because like while watching the scoreboard, I can't actually check what the problems are. Um, yeah, they I think yeah, they have been doing this since like I don't know how many years. Like they try to prevent leaks or something like that. I don't know whether there are participants competing online. Maybe there is. That's why they don't reveal problems while the contest is started. Um, yeah, EGOI is not sorted the tasks. Well, it's sorted by alphabetically of the title. At least that's what they're trying to do. Okay, so yeah, let's just start. Um, so okay, first of all, I'm not gonna lie. I have read problems ABC. I shouldn't have done that. Probably if I want to make like the stream like purely my first time reading the problems. But during my way back from work, I have read from ABC, and I think I have solved ABC also. But I'm going to go through my thought process as if I haven't solved it. Um, yeah. So I won't go straight to like my solution, but then I also like try to explain like my steps to go there. Yeah, problem A. I think someone already mentioned that it's super easy. Yeah. Yeah. So basically, the problem statement is a bit long, but basically the question is like you are given several numbers and you want to take out a sub array, a contiguous sub array, such that it does not have repeating numbers. The remaining numbers basically. So you want to out take out a sub array, contiguous sub array in the middle, so that the remaining numbers are all distinct, like they don't have duplicates, and you want the remaining numbers to be as many as possible, right? So you want to take out as few as possible, right? So for example, if this 1302023, you can take out the middle three or the suffix three. 102 you have to remove either 102 or 210, and then left with three numbers and so on, right? Yeah. So that's the problem. The constraint is 500,000. Actually, when I read this just now on my way back, I was with a friend that also like we read the problems together. We came up with two different solutions. I came up with a solution pretty much immediately. Yeah, this is not very hard. Like my solution is like if you keep track, like you can pre-compute first so that you can have a mapping between numbers and then their last occurrence index. Once you have that, you can do another for loop from the beginning to the end. And then, like, let's say here there's number one. With the pre-computation, you know where is the last index, that there is another one. That, that means the R can be at most that position, right? So basically, when you're increasing the L, you have to increase the R as well. This is LR is, yeah, the substring that you want to remove, right? So basically, if you're trying to like keep this number one, then the R has to increase as well, and that R has to increase as far as like where is the latest one that appeared in the array, right? And then when you say three, you also have to like when you see three, you have to like also check which position is number three appears last, and then you have to maximize it with number one. So yeah, I guess I can code this so that maybe by coding you get what I mean. Clear. Have to enable my Sublime. Oh, okay. Let me just do that. Okay. So like basically, yeah, just to what is the input and yeah, the n, and then like I have like want to get the furthest number for each 0 to t. I have to scan, of course. Yeah, I'll just run it on a sample. I can't submit it, unfortunately. I can't submit it yet. Okay, so I want to make the farthest of. Uh, is it guaranteed that each number appears at least once? Okay, that is great. I think I have to scan first. What is the variable name? AI. Okay. Um, And then I have to print the indices. The indices that I want to remove. Yeah, it's okay. I want to include this number, then I have to L becomes I plus one, and the R becomes like in 2025. Um, yeah, you can do that. You can do bracket. R is like something like R is like max R for this AI, right? And then I guess I have to like uh if this thing has been found before, then I have to break, right? Is it something like this? Yeah, should be something like this, right? Then this is just I want to move L and R, so guess answer should be this, and then like if this is greater than like answer second minus answer first. Yeah, sure, whatever you want. Should be something like this, right? Try a good directory to save this without refilling my file system. Okay. Oh, I need the compilation flag because I'm using a newer C++ version of creating pair. Okay, let's just run the samples. Uh, ah, Great. Yeah, of course. And this should be T. Row 4. Yeah, of course. Just remove everything, right? Smaller. 1, 0. Nice. Um, Wait, does this? Wait, now I'm so confused. And it's problem A. No, you have to. Come on. The R can't be like. Yeah. Okay. So the R needs to be at most E, E. Yeah, I guess 4 4 works. Okay, so that is fine. I keep pressing the wrong button. Not so used with Windows. 35023435 is fine. Yep. 7. Oh, it should be 26. Okay. Big solve. Why is it 7? Can we move on? 6. This be I minus. Ah, yeah, this should be. Yeah, 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 yeah. I have to test all the samples again. Okay, so that's 2 6. That's fine. That's 3 5. Okay, that's fine. That is 1 1. Okay. That is. Which one was this? This one. Sample output says 0 3, but I think 1 4. 1 4 is basically this. Yeah, that works as well. So that's fine. And the difference is the same. Oh, there's a lot of sample cases. So helpful. 2 3, that's exactly the same. And then 1 9. Yep. Okay. So that, yeah, I mean, we can't submit it. Okay, another solution that my friend came up with, basically, again, when I read this, I was with my friend and we read the problems together, is that you can do like a two-pointer solution where basically like you keep incrementing the value of L. Like basically you keep incrementing the value of L until you found duplicates. And then like um so basically keep L equals 0, R equals n minus 1, and then you keep incrementing the value L until you see duplicates. And then you, after you incrementing L as much as possible, then you try to decrement R again until you found duplicates. And then while you are reducing the value of L, you just decrement the value of R. So that should work as well. Yeah, basically like maximize L, minimize R. You found one of the solution, you decrement L and then keep decrementing R as much as possible, and then decrement L by 1, keep decrementing R as much as possible. Yeah, that should work as well. So yeah, you just keep an array found, and for every integer check if it's found. If it's the one that's already found, put L found, and for every integer check if it's found. If it is the first one that's already found, I am that I do. Yeah, I don't think that worked, right? Oh, that is the fake solve. Yeah, never mind. Sorry, I missed the solve thing after. Yeah. Okay, but yeah, that is the first problem. My browser just hangs now. Okay. My laptop suddenly so heavy. Just close unnecessary tabs. Okay, problem B. Okay, this is interesting. Like, to be honest, I didn't expect EGI to have interactive problems B because, like, in the past, problem A, B are usually still like pretty straightforward batch problem. Interactive can be a bit complicated. Like the setting by itself, like just by the nature of interactive problems, usually the setting takes a while to understand. Okay, but basically for this problem, there are n room um, and n switches. So basically, one switch controls one room, and it's a permutation. So, and you don't know which switch controls which room, and you can the queries are you can send which switches you want to turn on, and then the answer will be how many consecutive rooms, how many pair of consecutive rooms have different light mode, basically, right? So let's just go through the examples. So basically, let's say this is the permutation of the switches, right? Um, and then you want to switch on switch 0 and 4, then the judge will say, will return an integer 3 because between room 1 and room, the condition of the light is different. Room 2 and room as well, and room 3 and room 4 as well, right? So, yeah, so that's, then the judge, if you say, uh, like 10001, the judge will return you integer 3. So again, like you can send for each switch, you send whether you want to turn it on or off. You don't know the permutation, but then the judge will tell you how many pair of consecutive rooms have distinct light state. That is the problem, right? Um, okay, I'm just getting a Discord message that apparently the next EGOI is in Italy. I just got a message from someone in EGOI right now. They just announced next year's EGOI will be in Italy. But anyway, yeah, this is like super breaking news. Like I just literally got the message. Um, okay, yeah. So this is the problem. Um, and you have to do it with only 30 queries, and there are 30,000 rooms, right? So 30 queries, 30,000 rooms. Okay, and yeah, basically this is easy and less than 30 and the problem, oh sorry, the question is, what is the question, right? You don't need to find the permutation. I don't think that's possible, but you only need to find out which switch controls both endpoints. So you want to know which switch controls the first room and which switch controls the last room. That is the question, right? um yeah, okay. and and you can return in any order because it's impossible to distinguish which one of them, right? Like if the permutation is reversed, you can, like, basically you can't distinguish between p equals like 1 2 3 4 5 versus 5 4 3 2 1 with just the queries, right? You can see how, like, those two failures of p, regardless of what state the switches you send, they will always give you the same answer, right? So you can't distinguish between like p and the reverse of p, right? So that's why, like, basically they ask you to return the both endpoints, but you don't need to know which one controls room 0, which one controls room n minus 1. You just need to find which two switches controls the endpoints, right? Okay, so yeah, so I look at the sub, like when I read this problem, in contrary to problem A, I did not immediately find the solution. So like I think a bit, I look at the subtask. N less than 30 is pretty easy. You just turn on the switch one by one. Basically, if it's one of the endpoint, they will tell you one. The judge will tell you one. Otherwise, it's two, right? So subtask 2 is still pretty straightforward. Uh, Subtask 3 is where when I read subtask 3, it's where I gain my, like, biggest observation, I think. So biggest observation is that basically when you send a queries, if the first and the last row has the same state, like both are on or both are off, then the answer, the number given by the judge will be even, right? So because, like, basically in order to go from on to on, the number of state changes has to be even, right? Like it goes on to off, back to on, back to off, back to on, or something like that. But the number of state changes have to be even, right? So basically, only by checking whether the judge number is even or odd, you can know whether like uh, both endpoints have the same state light, right? So that is one of the biggest observation. And with that, you can solve subtask tree with binary search, basically. Uh, because like if you know that switch zero controls room zero, then you just need to know which switch controls room n minus one, and you can do that by basically binary searching. Basically, for switch one to switch n divided by two, you can turn it on. Keep switch zero turn off, and then if you know that if you try to turn on switch one until switch n over two, like, and then it gives you an even number, that means the last room is also off. That means the switch for the last room is somewhere in the later half, right? So you can do binary search to solve this uh subtask, right? Um, and then for this one, um, basically you know that one of the switch is in the first half, one of the switch is in the second half. What was my solution for this? I can't remember. Um, Basically for this you can do binary search twice, right? Basically because you know that one of the switch is like um is in the first half and the other switch is on the second half. That means if you turn off all of the switch in the first half, that becomes subtask tree to find what is the last switch, right? So yeah, you can do it in like log n over 2. And then to find the first half, you can do the same, right? You can keep all of the second half switches turned off and then do binary search on the first half, right? They will give you the the other output switch, the other switch, the other switch, right? And log of this is 15, so that's just exactly what you need, right? You, 30 queries is exactly what you need. Yeah. Okay. I hope that makes sense. Okay, and then for subtask 5, basically because you know how to solve subtask 4. So in this problem, actually, like the subtasks are very helpful. It gives you hints to like solve the problem. So once you can solve subtask 4, to solve subtask 5, you basically need to like find like two distinct group where like one of the one of the switch that you want to output is like on one half and on one group, and then the other switch is on the other group, right? How do you do that? I think this is pretty classic that you can do like basically binary. um okay, let's try to use the whiteboard this time. I say again, webwhiteboard.com, or let's just use Paint. Yeah, why not just use Paint? Okay, so basically we want to find um cursor. Okay, we want to find two integers a and b, to zoom out. Or more precisely, now we want to find set a and b such that a is in a and or like and b is not in x, right? Let's say x. Okay. Once we can find this set, then it's pretty much becomes subtask 4, right? Um, so the way we can do this is basically like do something like this. Like let's say n equals to 8. The last query is something like this. Okay. So by sending log n queries, you can get a set where like you can get a set of size n over 2 where like a is in one set, b is on the other set, right? This is basically like the first query is like checking whether like they are first bit is the same. This this query checks whether the second bit is the same, and this one checks whether the third bit is the same, right? And because A is different than B, then at least one of the bit is different. So by sending these queries, you will get like you will get one of the query where like A and the ith bit of A and B is different, right? And then once you able to do this, then once you find the set, one of the set, let's say this tells you that A and B is in different set, then you do the solution for subtask 4, right? So that will give you like a log n, I think times 3, right? Because the solution for subtask 2 is 2 times log n, because you're doing binary search twice. Um, and yeah, for this one, because you need another log n to find the set, then it's 3 times log n. But it should be okay because n is 1000, log n is 10, so 10 times 3 is 30, right? So that's all subtask 3. For subtask 6, there's no additional constraint, so 3 log n wouldn't fit. But actually, by doing this, um, you know what are the set of bits such that like you know the set of bits I where AI is not equal to BI. So once you find A, you can know the value of B as well, right? So actually once you know the set, you can only binary search one of the half and you will know the other half as well. I think that's the best I can explain. I hope that makes sense. Feel free to ask questions in the chat if you don't understand. But like, okay, in this problem, because it's an interactive task, there is actually a testing tool that I can use. So it's pretty convenient. So let's try to code this problem. Can I code with Python? Why do you want me to code in Python? Sure. How to flash on Python? Okay, so we read an integer and okay, so basically by asking like whether like basically I want to find for each bit whether like AI is different than BI. So we want to check basically we check whether the bit of I differs between AI and BI, and that gives us basically the SOR value. So basically like we, we know what is the SOR value. How to do this? Basically that is the string query, and then if like j and to the power of I is 0, then this is 0. Otherwise, this is 1, right? Uh, yeah. And then we print s. How do you flush on Python? Is it just flush bracket? There should be an example code, right? There you go. Dark right dot. Does print automatically flush? Does anyone know whether just doing print like that flushes like this? Okay, sure. Let's assume it is. Probably need the OS package. Okay. Okay. So we print that with an exclamation mark. And then we read a number. If this number is odd, print X flush true. Okay. So if this number is an odd number, that means AI and BI is actually different. So you want the SOR increment, the SOR value. uh, 2 power I, and then we can use this set to find out the value of A. Um, we can take a sample value of I, basically. Let's just get a set. A set. Append, right? The append. And then we do binary search. We do binary search. Then if mm, how to binary search? Um, uh, I guess this should be. And then I want for range L to M plus 1. I want to change this to 1. Okay. And then I ask this. If it gives me an even number, then I know that my answer is in there. Otherwise, my answer is not there. Right? And then A is L or R, same thing. So works. And my B is basically store value A, or that right? And then I can print. Okay, let's try that. Sample cases as well. I'm saving the sample cases. How do I do the testing tool? Like the Python 3. Do I have Python here? And then I do another Python py sample one. Sample one dot in no, it's sample one dot txt. Okay, yeah, sure. I'm always asking 11111. Great, useful solution. That's in Python. Do bitwise and or do I need to do? I need to do that. Yeah. Uh, yeah, that's much better. No pen. It's add. There's no add also. What is it? Oh, because I need to get it with an array. Pen. Uh, what? Okay. Okay. Fine. Here. Ah, string in Python is immutable. I have to do that then, and then I have to convert this to a string. Right? Finish running solution correctly solve test case. Okay, great. Okay. Okay. Yeah. That should solve the problem. Push. Yeah, sure. Does it work? No, it doesn't work. Okay, it's a pen. So I got it first time. It's just that I forgot to initialize it to an empty array. Hmm. Yeah, I guess I can test it with a slightly larger permutation. Wrong answer. Okay, that is why I should test it with a larger permutation. Why is it wrong too? Hmm. I answered 1 0. Distinct one is here. Okay. Oh yeah, A should not L, but A sub L. There you go. Yep. Mhm. There you go. Okay. Okay. Let's do problem three. Okay, problem three. Problem C is a bit trolling. um, but kind of fun actually. So basically there is 50 monster. Um, like basically 50 monster nest number from 0 to 49, and then like in each nest that in nest I there is an infinitely many monster of type I, right? And then like you have n friends, and then you these n friends they have a list of 12 monsters that they want to collect, monster types that they want to collect, and then all of these n friends will go through nests one by one in a random order, and then we want to construct the list such that there is a single unique winner, and a winner is determined by whoever first collected all of their 12 monster types in their list, right? So basically, um, and basically the input is only n, and we want to construct n times 12 numbers, right? So basically this is the list for the first person, and this is the list of the second person, and this is obviously work because like they don't even share the same monster type. So we know that there will never be a tie, right? What it can be a tie is if you like do something like this, right? Well, first of all, if you keep the list exactly the same, and there's this is obviously a tie, right? But even if like there is only an one intersection, like let's say you do something like this, then it is possible to have a tie as well if you visited like if the order of the nest that you visited like ends with zero, right? So like if nest zero is the last nest that you visit, then there will be tie as well, right? Need to test with n equals 10k. I mean, sure, I can generate a random permutation of like 30,000 even. Yeah, I guess I should do that. I should make sure that like what is it like the I my like I don't use too many queries. Oh. Is something called tc.jpp. This is a tc generator. Etc cpp. My generator does not compile. Happy now? Oh, it's sample 3. Never mind. Yeah, I should use like, yeah, you're right. No, I think the input is problematic. Yeah, I print n twice. What am I doing? Yeah. There you go. Yeah. I mean, yeah, it should be typed. I know it should be typed. Yeah. So just now when it says 16 queries, I know something is wrong. Okay. Let's go back to problem C. Happy now? Are you happy now that I tested with 10k? I just received another information that EGOI 2026 will be in May. It will be pretty early. Yeah, this year's is in July, right? And then next year they're planning to do it in May. Okay. Anyway, let's go back to the problem. Yeah. So basically, like this is one of the invalid output. Oh, I think I closed the file. Great. But yeah, basically, like you need to construct n lists so that regardless of the order of the nest that you visited, there won't be a tie. So n equals to 4, like basically because like there are 50 nests and each friend have 12 monsters, then n equals to 4 is a straightforward problem, right? Basically, the first person can just do this, right? And then the second person can do this and so on, right? You can imagine how it works, right? But then you can only have up to 4 friends. Oh, by the way, the score of this problem is basically just for for each value of n that you can solve, you get 2 points. Very straightforward scoring, right? Um, yeah, but basically, like you can then understand why there are like a lot of 8 points here because like yeah, like it's easy to get 8 points and it's slightly tricky to get more than 8 points. Like once you found out these 8 point solutions, what are the observations that you can do to go forward? Like it's not that intuitive. Um, But yeah, when I think about this problem, basically instead of 12, I simplified what if it's 3, right? Instead of 12, right? Then you can do like this kind of overlaps. Okay. Okay, first of all, and like a single overlap will not work, right? If you have like this, let's say, and then just now I show you like this won't work because what if nest 0 is the last nest that you order that you visit, right? So even a single overlap wouldn't work unless you do something like this, right? So like let's say there is an overlap there, but then you have to have this as well, right? So if you have like 0 1 and you have 0 2, then you have to have 1 2 as well. Because like that means if you visit a nest 1 and 2, then person 3 is the winner. Then there will still be unique winner, right? But if there's no here, there's no 1 2, then if nest 1 and no and nest 2 is visited, and then after that nest 0 is visited, then there will be ties. So if there is these intersections, we want to have this 1 2 as well, right? So it means we can construct something like this, right? So with this, am I zoomed enough on my brow on my like 96 points is unfortunate. Yeah, only left with like two failures of n that they can't solve. Okay. How do I in? Anyway, I assume this is big enough. Okay. Basically, if you can do this, then yeah, you're good, right? So that means you can do like and because it's 12 instead of 3, like each person wants to visit 12 monsters instead of 3 monsters, want to collect 12 monsters instead of 3 monsters, then you can basically assume that these are 6 monster. Each x of this is 6 monster. So basically you can do like person 1 0 to 5 and then 6 to 11, and then person 2 0 to 5 12 to what is it 17, and then person 3 6 to 11 12 to 17. This works, right? This works. This is a valid solution for n equals 3, right? Right? Because this is basically this, right? And each one of these x is basically like you have to visit all of monster 0 to 5, right? So yeah, but basically this works, right? Whichever like got two of their groups like completed, they will win, and it will be uniquely there will be unique winner, right? So this works, right? And then if you change like the factor of this x, so now this x represents like 6 monsters, right? Not 4, sorry. This x represents 6 monster. And then but then if you do this, then for each like 3 friends, you need to spend like 18 monsters, something like that, right? So that means you can do like 50 divided by 18 is like 2 point something. So that means with these solutions, you can have 6 friends, right? So basically your 6 friends will be something like this, right? Okay, right? So by using this solution, assuming that each of these x is 6 monsters, then you can have 6 friends this way, right? Um, and this is 36 monsters, right? So you don't even use monster 37 to 50, but we can't add 18 more, so we can't have nine friends, right? Because 36 times plus 18 is more than 50. Okay. But yeah, at least we can solve n equals 6, we get more points. And then what happened if you like change this x instead of represent 6 monster, why don't it just represent 1 monster? Okay. And then we can construct something like this, right? Okay. And this is a valid solution also. Okay, and so on, right? You can imagine the construction, right? And so on, right? I don't want to draw the rest, right? But basically, like, and assume this is 12 monsters, right? So basically, you can have 13 friends using only 13 monsters, right? You can solve n equals 13 with only 13 monsters. That means you duplicate this like 3 times, you can have 39 friends using only 39 monsters, right? Um, so you can solve n equals 39. And to be honest, at this point, like I was wondering why not so many people got 78 points, because I thought this is an easy solution, right? when I found this solution, like I thought I can solve like all n less than 39 because I thought like higher values of n should be harder. So like if I can solve n equals 39, then I should be solve every n below 39. Right? But so then I look at the scoreboard. I should get 78 points, but how come nobody got 78 points? Because I thought like it's an easy solution, but nobody gets 78 points. And then I realized that I only solve for only like n equals 13, n equals 26, and n equals 39, but I can't get n equals 38, right? Because like even though you can do this, if you remove one of the friends, the whole solution does not work, right? So with this construction, you are guaranteed that there will be no tie, but even if you remove one, then there might be tie, right? So removing any of them does not work. Like if we go back to this easy construction of three friends, right? We discussed before that removing the bottom one will not work, right? This might cause a tie, right? So we need to have all of them. So like this solution actually just adds me three more values of n instead of like 78 points. I just get six more points. Okay. Yeah. Um. But then like basically now it's like kind of like hinting where the solution is. Basically like if like I can use 13 friends with only three monsters. And then previously I told you I can use three friends with 18 monsters, right? So like you can see how I can get n equals 16 from this, right? With only 31 monsters, right? So we can mix and match like the number of monsters I want in each X, right? So yeah, basically that's pretty much the solution. And like I can also make it varying by like let's say instead of like only like one empty space, I can have two empty space, so I can have more friends. Okay, so this construction is also valid, and I can have like six friends here with each of these six is so 24 monsters, right? This construction is also valid, right? Because whoever like when like there are two blocks that are completed, there is a winner, right? So yeah, this construction is also valid, and this gives me six friends with 24 monsters, right? So by basically uh, constructing using any variance of this, try to find the like the sum, yeah, like you want to get the sum of xi to be n and the yi to be less than 50, something like that. This is xi friends with yi monsters, and there are different values of xi and yi that you can construct, and you want to find those that the sum of xi is n and yi is but yi must be less than 50, right? Because we only have 50 monsters to play with. Trading monster with friends sounds like a good deal. Okay, sure, yeah. Yeah, and then at this point, I need to code whether like it's possible for each n, but in earlier I already do some coding with DP. Let me see whether I can recover that code. Um, because I don't want to code again. Okay. So this is just finding a binomial coefficient, and then I'm using a DP. Whether like this is the number of monster left, and this is the number of friends that you want to fulfill, right? Okay, let me improve my variable naming a bit. Yeah. Okay. So basically, this f is a recursive function, and this f is basically should return one if I can like fulfill this many friends with this many monsters. So basically, the question is f 50 comma n. If I can do 50, f 50 comma n is a yes, then I'm good. So here I am just computing binomial coefficient, and then the DP is basically like if I don't have any more friends that I need to fulfill, then it's good. Otherwise, if I don't have any monsters left, it's bad. And then just memorization, and then I can just reduce any monster that I have. Um, I don't think this is needed. I can comment that out. And then basically now this is like basically I look iterate through the block size of each like X. How many monsters are in X that I show earlier. Mm, mm, mm. Okay. And then let's say the block size is 6. So X is 2. X is basically the number of X's for each friend, right? And then Y is like basically just now I show you like if this is the case, like basically uh, so for example, if I want to construct something like this, then the value of X is 2, Y is 3, something like that. Y is like basically how to explain that? Yeah, the amount of empty space plus number of X, right? And then basically by doing this, I can satisfy, I can fulfill like Y choose X number of friends, right? So that I can check whether the DP of this is possible, right? I can just recursively go through this function, right? Okay. And then it turns out that this satisfy all values of n. And then I try like uh I try to print n and then the function 50 comma n, and this prints all one just now. Ah, get my output. There you go. Yeah, see all of this is one. That means this is good. Then I have to backtrack to get the solution, the construction basically. But yeah, basically this just shows that this construction works, right? Okay. Um. Yeah. So this should satisfy all values of n. Okay. Now for problem B, I haven't read the problem myself, so this will be my first time reading the problem. Okay, and this will be pure like candid stream of like trying to solve this problem. Okay, let's read. Basically, we are given a graph. Okay. Oh, okay. Okay. So each edge has a cost. Okay, so each edge has a cost. Okay. Okay. So basically, there is a graph, weighted graph, and then you want to, like, initially all the edges are like inactive, and then like you want to activate the edges so that um you want to activate the edges with the fewest total weight as possible so that each node is connected to either of the node from L to R. Okay. Okay. Or like in other words, if you just basically add the edges connecting node Li to Ri, you want to find the MST, right? Okay, so Q equals 1 is E because it's just an MST problem. You just combine, yeah, you can just combine node Li to Ri to a single node, and then it's an MST problem, right? Basically, that's the problem, right? And Q equals 1 is basically just an MST problem because you can easily combine, you just combine the node Li to Ri to a single node. By combining, I mean basically if there is an edge connecting to either of these nodes, you connect it to this giant supernode as well, right? Basically, if there is a node from there's an edge from node one to node Li, you destroy that edge, you connect it to node one to node to this giant node instead, right? Um, okay, so that's Q equals one. Okay, did anyone get 100 points on this? Oh, okay. Yeah, I probably won't be able to get 100 points as well, especially since I'm a bit tired. This is late, but let's try to get as many subtasks as possible, or like as many observations as possible. Um, okay, subtask one should be easy. It's a line, and the edges, the nodes are consecutive numbers. Okay, so that means yeah, this is just you can just sum up the values of C minus uh the value of C that are used to combine the node, right? So basically, it's the sum of C minus CL minus CL plus 1 minus CL plus 2 minus R. So 8 points is E, right? That makes sense. Basically, all the other edges have to be built, right? Other than the edges that are used that are destroyed by combining the node, right? Okay. Um, this one, subtask 2, is is basically MST because the MST solution is basically Q times N, right? Uh, I don't know why there is a some requirement here. I don't think it's necessary. Yeah, even without some requirement, we should still be able to solve it. Okay, so that's 19 points. Okay, subtask 3 is interesting. So Ri equals to Li plus 1. So it will only combine two nodes. And there are only Q distinct there's only Q distinct queries, possible queries. Sorry, N distinct possible queries. instead of thinking like combining the node, you can also think of like adding an edge with weight zero. So like for subtask tree, basically like you want to find a spanning tree, a minimum spanning tree if node Li and Ri is connected by an edge of weight zero. That is also how you can think of this problem. Okay. So okay, I think I found a solution. Subtask tree. It's basically like just find a regular minimum spanning tree on the original graph, and then for each query you just find uh, the path between Li and Ri, what is the maximum edge weight in that path, and then you subtract the MST with that number, and that should be the answer, right? Basically, because you're connecting an edge from Li to Ri with weight zero, you can remove one of the edges in the path from Li to Ri, right? And obviously you remove the path, you remove the edge that has the maximum weight, right? So yeah, that should be, that should solve subplot tree. You can use like a heavy light decomposition or something to find the maximum edge weight among in the path of Li or to Ri. You can even use like sparse table, I think. Yeah, but yeah, any data structure, there should be a lot of data structures that you can use to solve that. Okay, so that's all subplot tree. So we get 32 points. Okay, yeah, and there are several 32 points here. Okay. Subtask 4. Ci is either 1 or 2. I feel like subtask 6 should be simpler. Like Li equals to 0. Again, it means there's only n distinct possible queries. Yeah, if you just answer from Ri equals n minus 1 first, does that work? So like if you just answer R equals n minus 1 first, and like R equals n minus 1, L equals 0, obviously the answer is 0. And then if you reduce the R equals n minus 2, then you have to connect node n minus 1 to either one of the remaining connected nodes. Choose the smallest one, obviously. Actually, the other way around. Like you solve for L equals to 0 and R equals to 0, which is basically just a normal MST. And then Then you try to increase r equals 1, and by increasing r equals 1, you adding an edge from 0 to 1, which is a weight 0. But then you have to recompute the MST, but can you just, again, find the maximum edge weight among the part from 0 to 1, but then you have to disconnect the edge, and then the trees becomes different, so the data structure has to be different. Okay, that doesn't work. I feel like the edges used is always the edges from the MST of the whole graph. That should true, yeah. Uh-huh. There is no point using edges that is not the MST of the original MST, yeah. Okay, so basically you want to, okay, basically once you find the MST of the original graph, you want to destroy like R minus L edges such that, and you want the destroyed edges, the total weight of the destroyed edges to be as large as possible, such that each node from Li to Ri is in a different connector component, right? That is correct, right? So uh, you want to destroy R minus L edges so that each node in L to R is in different connector component. Let's solve subtask 6 by just adding the value of R. You just find, by just increasing the value of R, you just need one more edge to be destroyed. But does this previous set of destroyed edges can be kept destroyed for the next value of R? Oh, I'll go. But like if you think of that way, like if you think of like destroying the edges, how do you solve it for one query? Yeah, I guess like wait, I'm not expert. I'm not familiar with like dynamic MST. I think there is like it's a thing, right? Like there is a thing called dynamic MST, but I don't know like what is how dynamic can it be? But like if it's basically like can support addition and removal, then that can be used to solve this problem. Because basically, yeah, as you say, like if you want to use more algorithm here, basically like adding one more node is like adding an edge Like if you want to increase the value of R, basically it's basically like from R to R plus one is adding an edge from node R to R plus one with weight zero, and then decrementing is basically removing that edge, right? So if there is an MST, if there is a data structure that can dynamically compute MST on edge additions and removal with weight zero, then yeah, that would solve the problem. But I'm not sure whether there is such data structure. Did I participate in any EGOI before? Yes, I did. In 2013, when freaking art class was there, that is probably the worst problem in the history of IOI. Yeah, if you don't know what that is about, Google IOI 2013 problem art class. I hate that problem. And I competed in 2012 as well. But I hate 2013 more, even though I get a better medal in 2013. If you go that route, I'll definitely involve Linkatri, but I think there should be a simpler solution for this. And I wouldn't be surprised if the solution is Linkatri. Like this is the last problem of day one, so like I wouldn't be surprised if they just put a stopper, like making sure no one get a full solve or something like that. Like, they put an extremely hard problem. Plus five is also interesting. Like the sum of R minus L is small, so we can actually add the edges. Like we can add those edges with weight zero, but then like we have to recompute the MST quickly. And I'm thinking whether for each addition can remove an edge. Okay, yeah. Can you solve subtask 5 with like basically similar to subtask 3, but instead of like destroying the edge, you like change the edge weight to be zero. So like you try to you're given a Li to Ri, first compute the MST, and then you find the path between node Li and Li plus one, And on that edge, on that path, you change the weight of the heaviest edge to be zero. So the structure of the tree doesn't change. You can update the edge weight so that, and then again for node Li plus 1 and Li plus 2, you do the same thing. You find the, no, that doesn't work for me. Because you might actually, yeah, imagine if like node, like imagine if you have Li plus 1 and Li plus 2 in a line, but Li plus 2 is in the middle. When you want to destroy one of the edge from Li to Li plus 1, you have to destroy the correct edge. What's the best strategy to practice for IOI? Do past IOI problems? Uh, yeah. Um, yeah, I guess go through the syllabus. Like, make sure you understand all the concepts first. Um, yeah, like the good thing about IOI is there is syllabus, unlike like ICPCs, where like anything can come out. Um, so yeah, basically like going through the syllabus and make sure like for each like concepts, like I think the syllabus even like mention technical terms, technical algorithms like MST, short spot, Dijkstra. Yes, AI has a syllabus. Um, yeah. So first of all, make sure you understand those concepts. Um, of course, it's not enough. Like IO problems is not just finding a short spot. Obviously, like given a graph and find a short spot, it'll be like some complicated problems that like um that require that, and then you can reduce it to a short spot problem or like MST. Oh yeah, read the editorial as well if you're like basically for harder problems if you can't solve it, read the editorials. Going back to this problem, yeah, I don't know. So we solve subtasks 1, 2, and 3 for now. That is 32 points. So we get 332 at least. Right, second place, get 62. So that's solved everything except subtask 4 and 7. Okay, yeah, basically we'll need to like we'll need to solve this subtask as well to get 62 points. Yeah, I feel like subtask 6 is very approachable. Like it's basically like going from R from 0 to n minus 1 or the other way around because there's only n distinct possible queries. Okay. No, I don't know. Um, yeah, I'll think about this offline. Anyway, in 2 days' time, like the day after tomorrow, there will be the second day of the competition, and I'll probably do the same thing again. And at least it's Friday, so usually I'm more relaxed on Friday. Um, yeah, I'll try not to read the problem before streaming next time. So even like I'll start reading problem A once my stream starts. So you will see my candid reaction of reading the problems in the stream, and like I will start thinking on the stream itself, so I won't be spoiled of any solution. Uh, yeah, and yeah, see you on Friday, I guess. And if you know how to solve D, you can put in comments or chat or whatever. Okay, time to rest. See you, everyone.